Hello everyone, I'm Amirul. I'm going to present our work, Visually Guided Audio Source Separation with Meta Consistency Learning. We consider the problem of visually guided audio source separation, where the main goal is to learn to separate objects, sounds by watching unlabeled video, and we follow the setup from prior works where all the sounds in the video can be related to on-screen objects. Here are the motivations of our work. Recent successful end-to-end approaches adopt a single network with fixed parameters to generalize across unseen test videos. So these methods are limited to the scenario where both train and test set contain similar objects, for example, musical instruments. Naively adapting the model parameters via the self-supervised objectives can lead to catastrophic forgetting. So here is a summary of our contributions. So we propose a novel framework for visually guided audio source separation in the context of both known and unknown musical instruments. We introduced an effective meta consistency driven test time adaptation scheme that enables the pretrained model to quickly adapt to unknown music videos. We provide experimental evidence that our method improves generalizations to both known and unknown musical categories. Let's look at the overall approach of our proposed audiovisual separation network. The Visual Guidance Network extracts multimodal representation (FAV) from the video frames and mixed spectrogram (SM). The mixed spectrogram is also fed to the audio separation network, which generates the encoded audio feature FA. Then the multimodal representations FAV is combined with the audio feature, resulting in a guided audio feature. The decoder of the audio separation network takes this representation as input and outputs separated audio spectrogram mask. We then design a self-supervised cross-modal consistency objective as an auxiliary task that learns synchronization between the audio and its corresponding visual embedding. So we also introduce a meta consistency training framework for audiovisual source separation. So with the ultimate goal of further improving the separation results and adapting to known and unknown samples. During the inner loop training, given an audiovisual pair and the parameters of pretrained model theta, we perform a small number of gradient updates on the input pair using the consistency loss. An outer loop updates the source separation network using mask prediction loss. We first evaluate our method on music test set and compare with recent state-of-the-art methods. As we can see, our method outperforms all the existing approaches in terms of SDR and SIR metrics. So to show model compatibility to separate sounds of unknown musical instrument, we evaluate our framework on the Music 21 dataset. More specifically, we use the model pretend on music dataset and adapt it on each sample of the Music 21 single source test set. So as you can see, cross-model consistency learning promotes the separation results more aggressively when adapting to unknown music classes. We further evaluate on Music 21 multi-source test set. We see the similar trend that cross-model consistency based on meta learning achieves best performance. So here we show the illustration of SDR after each gradient update for fully meta-trained models trained with different number of Ks. For example, K equal 1, 2, 3, 4, and the pretend consistency model with no meta training on music and Music 21 test set. So interestingly, test time adaptation with small number of inner loop updates shows the most SDR gain, while the separation performance is diminished with more gradient updates. Here we illustrate the unfolded adaptation process for various number of gradient updates during test time adaptation. Interestingly, cleaner and visually closer to ground truth separated spectrograms are generated with K greater than 2. So to conclude, we introduced a novel method for visually guided audio source separation. We designed a cross-model consistency learning module that learns the synchronization between visual embedding and its corresponding audio embedding to improve separation performance. We integrated meta consistency learning to constrain the model so that the gradient updates via the consistency laws bring in the performance improvement and promote the ability for faster and effective test time adaptation. We also shed lights on the extension to a more universal sound separation, which will include off screen sounds in an interesting future direction. Thank you, everyone.